All right, in the next section, you're going to find the perimeter and area of different geometric shapes. So remember, perimeter, I'll just put it up here, means to add up all the sides. So for some of them, you'll be able to count, and for others, you'll have to use the distance formula or another strategy to find out how long each side is, okay? So for a right triangle, the way it looks is we're going to have 3 sides, and a right angle will be given. So the area formula is area equals 1/2 times the base times the height. So the height is the straight height, and the base is going to be the bottom, and they might turn these all around. An equilateral triangle is also a triangle, but equilateral means that all 3 sides are the same or equal. So when I draw a picture, we know this, this, and this, okay? So we've got, let's say this is 5, 5, and 5. So the area formula for this, though, is still area equals 1/2 base times height, except the height is the straight height and the base is the bottom length. All right? An isosceles triangle means that at least 2 sides are the same. Okay, so an equilateral triangle is also isosceles since that has 3 sides the same. So an isosceles triangle, we'll just draw it like this. So these 2 sides are usually equal. That third side is not equal, even though it might look like it on some of them. And so same thing, our area formula is still 1/2 base times height. The height is the straight height, and the base is the bottom. And just for any other triangle, because we might have a triangle that looks like this, let's say, an obtuse or a different acute, we've got the area is still 1/2 base times height. Depending on your triangle, you'll have to figure out how tall it really is, and then the base. Okay? So for a square means that all 4 sides are equal or congruent, since we're geometric shape. So I've got either by lengths, but all those sides are the same. So the formula is still length times width, but since all sides are the same, we're going to call it side squared, which is really length times width. So this would be a side. A rectangle means that opposite sides are equal and parallel. So plus right angles at all corners. So this is congruent, and these 2 are congruent. So the formula is length times width. So here's my length, here's my width. A rhombus, I kind of think of as a kite. So a rhombus has opposite angles that are equal, and all the sides are the same. Okay, so like this angle is the same, and this angle is the same. I call it a kite. So the area formula is still base times height. So I'm going to turn my picture sideways. So I would make this my base, and then we need to figure out how tall the object really is. All right. So it's going to be the same idea for a parallelogram. A parallelogram, it's kind of like a rectangle, but the angles are not 90 degrees. So opposite sides are equal, and opposite angles are equal. So the formula here is still base times straight height. So here's my base for the bottom, and then we got to figure out that straight height. All right. A trapezoid, they can look very different, but I'll draw one that's kind of, all right. So on this one, we've got opposite sides are parallel. And so sometimes if you look online, you might see arrows. That means parallel. So one pair of sides are parallel. The angles still all add up to 360, but they don't have to be the same. So this formula is height over 2, base 1 plus my base 2. So it's the straight height. The top is my first base, and the bottom is my second base length. Isosceles trapezoid is the same idea, except it's more specific, and that my two sides are parallel, but my two legs are also equal length. So, same formula though. We just name it differently, but we wouldn't do any calculations differently, so you can do that the same up there. This is my height, base 1, base 2. Now, a pentagon, we're not going to be finding the area of that, and we're not going to be finding the area of a hexagon, but a pentagon has 5 sides, and a hexagon has 6 sides. But we will find the perimeters. So let's look at our first shape. First, they want us to classify it, so I know it's a type of triangle, but I need to find out the lengths of those sides. And I need to find that for perimeter as well. So our bottom length is 1, 2, 3, 4, 5, 6. And then our sides, they're diagonal, so I can do our distance formula. So I'm going to do it here. We've got x minus x squared plus y minus y squared. So you can type that into the calculator. 3 squared is 9. Negative 7 squared is 49. So this is going to be root 58, which is approximately 7.62. Now, I notice this one goes to the right 3 and up the same, and this one goes to the right 3 and up the same. So if that's 7.62, this is also going to be 7.62 based on symmetry. So, since these two sides are equal, this is an isosceles triangle. The perimeter, if I add all 3 of those together, we would get 14, 20. Let me add. We've got 7.62 plus 7.62 plus 6, which is 21.24. Our area is 1/2. Our base is 6. And our height is the straight height. So 1, 2, 3, 4, 5, 6, 7. So if we type that into a calculator, we'll get 21 square units. All right, on my next shape, we've got a 4-sided shape. So that is definitely just going to be a quadrilateral. Okay, it's not going to be a trapezoid because we don't have any parallel sides. Our perimeter, so we need to find 1, 2, 3, 4, 5, 6, 7, 8. That's the quickest one. So then I'll have to do a couple of distance formulas. So I'll do this one, AB. So I've got x minus x plus y minus y. So we get 1 squared, 5 squared. So we get the square root of 26, which is about 5.10. Okay. And then we've got BC. So x minus x, y minus y, which gives us negative 5 squared, negative 2 squared, so root 29. 5.39 about. And my last side, which is CD. So x minus x plus y minus y, negative 2 squared, 7 squared, which is root 53, and it's about 7.28. So if we add all of those together, we get 25.77. Now, the area of this shape, since it's not a square or a rectangle or a parallelogram or a rhombus, we're not going to be able to find the area of that shape. So if you get like a pentagon or a hexagon, you won't find that either, okay? And on the last one, I can tell by looking, these sides are parallels because I went up and over the same amount, and the same thing with those. They're the same distance apart when I look at the squares. And opposite sides are equal, but they're not all the same. So this is called a parallelogram. So my area is going to be base times height. So I can do that one. If I turn my shape sideways, I know my base is, it's a little hard to see, but we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then this one also is going to be 12. And then my height, I went 1, 2, 3, 4. So I've got 12 times 4, and we're 48 square units. For my perimeter, I'm going to have to find these other two side lengths. So this ordered pair is at 2, and then 1, 2, 3, 4, 5. And then this one is at 1, 2, 3, 4, 5, 6. 6, 7, 8. So if we do the distance formula, we've got x minus x plus y minus y. So 4 squared plus 3 squared is 25, and the square root of 25 is 5. So I get 5 plus 5 plus 12 plus 12. So 24 plus 10 is 34. All right.